Yeah. So welcome to Quantum Online Academy. Yeah, today we are going to start with thermodynamics and statistical physics. So already we discussed four papers we finished. One is mathematical methods of physics. Almost more than 50% of syllabus we covered because mathematical methods of physics core and advanced we finished. Similarly, second paper is classical mechanics, that one also core and advanced we finished, and the third one is electromagnetic theory, core and advanced we finished. Later, so the last paper we finished, that quantum mechanics core and advanced part we finished in our app. Not only in app, in YouTube also I uploaded some videos, the question solving techniques I uploaded from each and every word of these four papers. Now we are starting the thermodynamics and statistical physics. Clear? So this is very important chapter because this chapter also core and advanced part is there. This is the fifth chapter according to your CSIR syllabus. Clear? Today in this class we are going to discuss about only introduction of thermodynamic and statistical physics. So why thermodynamics came, what are the foundational foundations are there in the thermodynamics. So those things we have to discuss in this video. So please concentrate, this whole thing is theory based, so that's why I wrote the theory, just you have to give the information to you, because you know that in 8th class onwards this thermodynamics started. Right now till now in the PG also the same thermodynamics is existing, because without thermodynamics we can't sustain in our human life. So what is the thermodynamics? First you have to see a thermodynamics originated from thermo. Thermo means heat, dynamics means power. Thermodynamics means heat power. So which one it is? Thermodynamics. Thermo means heat, dynamics means power. Suppose you have to take a matchbox and you kindled it, so what will happen? A flame of fire should be arises. So this flame of fire, it will give the heat, so that heat should give the power also. So that's why thermodynamics, heat it will give always the dynamical phenomena. Thermodynamics is a branch of physics. Thermodynamics is the branch of physics that studies the effect of changes in temperature, pressure and volume. Thermodynamics is a branch of physics that studies the effect of changes, in temperature, pressure and volume, on physical systems at a macroscopic level. Which level? At the macroscopic level. Once again you have to listen. Thermodynamics is a branch of physics that studies the effect of changes in temperature, pressure and volume on the physical systems at the macroscopic scale. Clear? Thermodynamics is the branch of physics. One more definition also I am giving to you. Thermodynamics is the branch of physics which we deal with the internal macroscopic state of the system. Which one it is? Internal macroscopic state of the system we have to deal in the thermodynamics concept. Thermodynamics is only concerned with a large scale of observation. Thermodynamics only concerned with a large scale of observations. So that's why this thermodynamic is a macroscopical phenomena. Thermodynamics takes no account of the atomic constitution of the matter. Means internal structure of the atom it won't consist. Thermodynamics take no account of the atomic constitution of the matter. These are the introduction of the thermodynamics. Thermodynamics is the combination of two terms, one is thermo, another one is dynamics. Thermo means heat and dynamics means power. Thermodynamics is a branch of physics that studies the effect of changes in temperature and pressure and volume on physical systems at the macroscopic level. Thermodynamics is the branch of physics which we deal with the internal macroscopic state of the system. Thermodynamics is only concerned with a large scale of observations. Thermodynamics takes no account of the atomic constitution of the matter. Clear? Now you have to see some more information I am giving to you based on the thermodynamics. Thermodynamics is a branch of thermal physics. Branch of thermal physics means thermal means that is heat. So we are studying about the heat. Thermodynamics is a branch of thermal physics which deals with the transformation of thermal or heat energy into mechanical energy or vice versa. In the thermodynamics, a energy is transformed from heat energy to mechanical energy or mechanical energy to heat energy. So there is a vice versa phenomena also is there. So what we have to write it is thermal energy, you able to take it as a thermal energy, which one? So thermodynamics deals with thermal energy is going to become as a mechanical energy. This mechanical energy will going to become as a thermal energy. Mechanical energy is going to become as a thermal energy. The reciprocal is there or vice versa. It also deals with the transformation of heat energy to other forms of energies such as electrical energy, chemical energy, light energy, and so on. Whatever it may be, you want to get it, you may get it. So thermodynamics deals with the transformation of heat energy to other forms of energies. What are those other forms of energies? The other forms of energy such as electrical energy, chemical energy, light energy, and so on. Thermodynamics is an empirical or experimental science. Thermodynamics is an empirical or experimental science, and the laws of thermodynamics have been developed by means of the observations and experiments over a long period of years. This thermodynamics, this is very important. Thermodynamics is an empirical or experimental science. The laws of thermodynamics, thermodynamics 0th law, thermodynamic first law, thermodynamic second law. So like that, so many 3 laws are there. So these laws of thermodynamics have been developed by means of observations and experiments. Over a long period of years. The genealogy of thermodynamics is developed. Thermodynamics was formalized as a science in the 19th century. Thermodynamics formalized as a science in the 19th century by the first scientist is Joule. He belongs to 1818 to 1889, and later the second scientist is Kelvin, 1824 to 1907. The third scientist is Clausius, 1822 to 1888. The fourth scientist is Carnot, 1792 to 1832. Lastly, Gibbs came. So he belongs to the 1839 to 1903. Developed and broadened its scope such that thermodynamics today is extensively used in all branches of science and engineering. to analyze the physical and chemical changes. Clear? This is the brief introduction about the thermodynamics. Now we have to see the basic term is in the thermodynamics is temperature. So what is the temperature? It is a measure of degree of hotness and coldness of a body. What is the temperature? It is a measure of the degree of hotness, and coldness of a body. The degree of hotness and coldness of a body, we call it as a temperature. Temperature is a scalar quantity. The units of temperature is Kelvin. The units of temperature is, what is that? Kelvin. The scale of temperatures. The scale of temperatures, once you have to see, the first one you have to take it as a degree centigrade. This is the first scale of temperature. Later you are going to get it as a degree Fahrenheit. This is the second scale of temperature, degree Fahrenheit. So the third one you have to see degree Kelvin. This is the third scale of temperature you have to see. Now you are going to take it as a fourth scale of temperature is degree Rankine. You have to take degree Rankine. So which one you have to write? It is degree Rankine. So this is the fourth scale of temperature. Suppose if you want to find out unknown, so what you are going to take? X unknown you have to write, it is here. We need to calculate x unknown also. Suppose you have to see the base points I will give to you. So in the Celsius and so in degree centigrade, in degree Fahrenheit and degree Kelvin and Rankine and x unknown. Suppose you have to take, this is the first one, this is the degree centigrade. So this one you have to take it as a degree Fahrenheit. The third one you have to consider as a degree centigrade. The fourth one you have to take it as a Rankine you have to see. So in the first you have to consider as a steam point, I have to consider. So which one you have to consider as a steam point you have to see. In the degree centigrade, so what is your steam point? Your steam point is 100 degrees centigrade. At 100 degrees centigrade, so your water should be become as a vapor. At 100 degrees centigrade, your water should become as a, how it will become? So that water should become as a vapor at 100 degrees centigrade. Clear? So once again you have to see, at 100 degrees centigrade, that water should become as a vapor. You able to take at 100 degrees centigrade, that water should become as a vapor. Clear? At 100 degrees centigrade, that water will become as a vapor. In degree Fahrenheit, so what is that? 212 degree Fahrenheit. 212 degree Fahrenheit, this is the steam point in terms of the Fahrenheit. In terms of the Fahrenheit, what is this? This is the steam point. So now you have to take, so what is the, in terms of degree Kelvin, what is the steam point? 373.15. 373.15 degree Kelvin in terms of Kelvin, that is the steam point. Suppose you have to take a Rankine, 671.67 degree Rankine. So this is the steam point in terms of the Rankine you have to see. Clear? So this is the steam point. Suppose if you have to take it as a ice point you have to consider. So what is the ice point? What is the ice point you have to take? In terms of the degree centigrade, 0 degrees is the 0 degree centigrade. So 0 degree centigrade is the ice point in terms of the degree centigrade. Now you have to see here, in degree Fahrenheit, 32 degree Fahrenheit is the ice point. 32 degree Fahrenheit is the ice point in terms of the Fahrenheit degree centigrade. And in terms of a Kelvin, 273.15 degree Kelvin. This is the ice point to 273.15 degree Kelvin. In terms of the Rankine, you have to take, so what is your ice point? 491.67. 491.67 degree Rankine you have to take. This is a, which one it is? This is the ice point. Clear? So, once again I will draw to you. Suppose you have to see what you are going to get it. So, here to measure the temperatures, so we have 4 scales I am giving to you. So, we measure the temperatures. I am going to give how many scales I am going to give to you. First scale is degree centigrade. Now, you have to see the second scale is degree Fahrenheit. The second scale is degree Fahrenheit. Now, the third scale you have to see what is your third scale. Your third scale is degree Kelvin. Suppose you have to take your fourth scale. This is the degree Rankine you have to take. We need to calculate. How we have to calculate? Suppose unknown, because we do not know this one, x unknown you have to take here, x unknown you are going to take it as a x lower value we are going to write it. See here. So, now you have to take the first point. What we have to write it is, the first point we are going to take it as a steam point we are considering. Under the steam point, what is the degree centigrade? 100 degree centigrade. If you want to boil the water, when it will steam will come 100 degree centigrade. In the degree Fahrenheit, so 212, so 212 degree Fahrenheit it will come. This is the degree Fahrenheit. In the degree Kelvin, 373.15 degree Kelvin you have to take. This is the steam point under the Kelvin degree centigrade. Now, you have to see the Rankine, 671.67 degree Rankine. So, this is under the Rankine scale, that is the steam point you have to take. Now, the second one you have to consider as a, for a normal temperature you are going to take, normal body temperature you have to write it is. Maybe you have to go to the clinic. So, doctor will test to you. So, what is your normal body temperature they will test. So, what is the normal body temperature? So, in terms of the degree centigrade, your normal body temperature is 37 degree centigrade. This is your normal body temperature. What is that? 37 degree centigrade is your normal body temperature. Suppose you, in terms of the Fahrenheit, 98.6 degree Fahrenheit, this is the normal body temperature. Suppose you have to take a thermometer, the thermometer is indicated in terms of the Fahrenheits, degree Fahrenheits only. Suppose if you have to take a degree Kelvin, how much it will come? 310.15 degree Kelvin in terms of the degree Kelvin. This is the normal body temperature. So, in terms of a Rankine, how we have to write it is 558.27 degree Rankine you are going to get it. This is the normal body temperature in terms of the Rankine. Suppose if you have to take, so already I am giving to you what you have to write it is ice point you have to consider. If you have to consider as a ice point in terms of the degree centigrade, that 0 degree centigrade is the ice point according to the degree centigrade. Now, you have to see here under the Fahrenheit, 32 degree Fahrenheit, this is the ice point in terms of the degree Fahrenheit. Suppose you have to take in a degree Kelvin, 273.15. 273.15 is the degree Kelvin. In terms of the degree Kelvin, you have to write it is. In terms of the Rankine, 491.67. 491.67 degree Rankine you have to take. This is the ice point you have to write it. Suppose you are going to that 0 to minus, you have to go at minus 18 degree centigrade. At minus 18 degree centigrade, you will get it as a 0 degree Fahrenheit you are going to get it. So, 0 degree Fahrenheit you are going to get it. So, 0 degree Fahrenheit you are going to get. So, whenever it will be equal, so your Kelvin 255, 255 degree Kelvin. This is going to equal to the 0 degree Fahrenheit, and in terms of the Rankine you have to see 459.67 degree Rankine you are going to get it. So, these are the values. So, you are going to get it as a 0 degree Fahrenheit corresponding to that. So, whenever it will become as a degree centigrade and Fahrenheit, so minus 40 degree centigrade, so will going to become as a equal to minus 40 degree Fahrenheit. So, minus 40 degree centigrade is equal to the degree centigrade and Fahrenheit, you are going to get it. Now, you are going to take it as a last value. So, what is the absolute value? So, we are going to take it as a absolute 0. You are going to take it as a absolute 0 values in terms of the degree centigrade, in terms of the degree Fahrenheit, in terms of the Rankine we have to write it is, what is the absolute 0 value? Minus 273.15 degree centigrade. This is the absolute 0 value in terms of degree centigrade. In terms of the degree Fahrenheit, so what is the absolute value? Minus 459. Minus 459.60 degree Fahrenheit. This is the absolute value you have to see it is. Now, you are able to take, so what is your absolute value of the degree Kelvin? So, this is the 0 is the absolute value of the degree Kelvin. So, now you are able to take what is the absolute value of the Rankine? So, the Rankine degree is equal to, that is also 0 is the absolute value of the Rankine. So, you have to remember, so what is the steam point and normal body temperature, ice point, whenever the degree centigrade is equivalent to the Fahrenheit, and absolute 0 values you have to remember, clear. So, not only that, so you are going to take it as a, I am going to give the pictures of that. Suppose you have to take here, so degree centigrade, degree Fahrenheit and degree Kelvin, and Rankine scale diagram I am going to give to you. So, the what are the major important things I am already given to you. So, what are those things? Once you have to see the boiling point, that is the steam point 100 degree centigrade. So, the boiling point is 100 degree centigrade, and so the corresponding to the degree Fahrenheit 1212 degree Fahrenheit, and in terms of the degree Kelvin 373 degree Kelvin, in terms of the Rankine 671. What we have to write it is 671.67, that is going to take it as a 672. So, the human body temperature, so what is the human body temperature in terms of, so this is the second one, 37 degree centigrade, and in terms of the Fahrenheit 98.6 degree Fahrenheit, in terms of the Kelvin 310 degree Kelvin, in terms of the Rankine 558 Rankine you have to see. So, the freezing point of the water, the freezing point of the water means that is the ice point, you have to take 0 degrees. So, the 0 ice point in terms of the degree Fahrenheit 32 degree centigrade, the ice point in terms of the degree Kelvin 273, and you have to say the ice point 492. So, 492 you are going to get it. So, not only that, the sublimation point of the dry ice, this is the sublimation point. So, minus 79 degree centigrade, the sublimation point of dry ice, so is minus 79 degree centigrade. The sublimation point of dry ice of Fahrenheit is minus 109 degree Fahrenheit. The sublimation point of dry ice in terms of the Kelvin is equal to 195. The sublimation point of in terms of Rankine 350 you have to take. So, the boiling point of the liquid air, the boiling point of the liquid air is minus 194 degree centigrade. The boiling point in terms of the degree Fahrenheit minus 318 degree Fahrenheit. So, the boiling point of in terms of the degree Kelvin is 79. The boiling point of liquid air in terms of the Rankine is equal to 142. So, now absolute 0 is equal to minus 273 degree centigrade minus 459, that absolute 0 is equal to minus 459 degree Fahrenheit, the absolute 0 is equal to 0 degree Kelvin. So you have to write it is in terms of the Rankine, that is the 0. So these things I have to given to you. So once you have to take so the boiling point of the water, the human body temperature, the freezing point of the water, the sublimation point of a dry ice, the boiling point of the liquid air, and absolute 0. So these values you have to remember. How we have to convert? So how we have to convert? To convert this, we are going to give one important formula I am going to given to you. So that is the degree centigrade, you have to take it as a C minus the minimum value is equal to 0. How many divisions are there? 100 divisions are there. The similar you have to take it as a degree Fahrenheit is equal to F minus 32 is divided by the ice point is 32 degrees. So how many divisions are there in degree Fahrenheit? 180 divisions are there. Suppose you have to take it as a degree Kelvin. So K minus 273. So this is divided by, so you are going to take how many divisions are there in the Kelvin? 100 divisions are there. Suppose you have to take it as a Rankine. So Ra minus 492 is divided by the ice point is 492. How many divisions are there in the Rankine? 180. So which is equal to, you are going to calculate as a x value. So x lower limit is divided by x unknown value. So x unknown value minus x lower limit, you have to write it is x unknown value minus xl, that is the xl means x lower value you are going to write. Based on this formula, you are going to take it as a, this is very important formula to convert degree centigrade to degree Fahrenheit to degree Kelvin, degree Kelvin to degree centigrade, or Rankine to Kelvin, or anything you have to convert it. Suppose I am giving one example to you. So I am giving one example. So what is your example? Our human body temperature is, so what is that? 37 degrees centigrade. Suppose 37 degrees centigrade is equal to how many degree Fahrenheit? 37 degrees centigrade is equal to how many degree Fahrenheit? How we have to calculate? First you have to see. So these two expressions you have to compare. The C minus 100, C minus 0 is divided by 100 is equal to F minus 32 is divided by 180. So they are giving the C value. So what is the C value? 37 minus 0 is divided by 100 is equal to F minus 32 is divided by 180. So now you have to cross multiply. You are going to get it as a, so what you are going to get? F minus 32 into 100, F minus 32 into 100, which is equal to 37 into 180. 37 into 180 you have to write it is, so 1010 get cancelled. So F minus 32 is equal to, F minus 32 is equal to 37 into 18 is divided by 10, you are going to write it is. So 18 is divided by 10, you have to write it is. So therefore, so you able to take as a 37 into 18 is divided by 10, which is equal to 66.6, you are going to get it. So now therefore F minus 32 is equal to 66.6, F is equal to 66.6 plus 32, which is equal to 98 degree. So this is the Fahrenheit you are going to write. Already we know that for a 37 degree centigrade is equal to, so in terms of the degree Fahrenheit, 98.6 degree Fahrenheit you are going to get. So this formula you have to remember. So through this formula you have to identify any one of the unknown value, or any one you have to take it as a x value also, you are going to get it. So not only that, so I am going to give some more important formulas I am giving to you. Suppose you have to use, if you want to calculate the degree Fahrenheit, if they will give the degree centigrade, so this formula you have to use it. So 32 plus 9 by 5 into degree centigrade. 32 plus 9 by 5 into degree centigrade you have to write it is. So you are able to write, if you have degree centigrade you have to apply here, you are going to get it. So not only that, you are going to take degree centigrade is equal to, how you have to find out, so degree Fahrenheit minus 32, degree Fahrenheit minus 32 is divided by 5 by 9. So you have to use this principle. Now you able to take it as a Rankine. So the Rankine is equal to, how you have to write it is degree Fahrenheit plus degree Fahrenheit plus 460. 460 you have to use. So degree Kelvin is equal to, you are going to use this formula, degree centigrade plus 273. So this formula I have to use so many times. We have to convert into the degree Kelvin in our problems after some time. Clear? So like this you have to use, these are the very, very important formulas. The degree centigrade, so if they give the degree centigrade, by using this formula you have to calculate as a degree Fahrenheit. So by using this one, you have to see degree Fahrenheit they will give, you have to use this formula, you have to calculate the degree centigrade. So if they give the degree Fahrenheit, so you able to find out the, use this formula, you have to find out the degree Rankine, and if they gave the degree centigrade, you have to calculate as a, which one you have to calculate, degree Kelvin you have to calculate. So these are the brief introduction about, so what we have to write it is, these are the brief introduction about the temperatures, the temperature in how many scales we are going to introduce. So we are going to introduce the degree centigrade and degree Fahrenheit, degree Kelvin and degree Rankine we are introducing. So not only that, so we are going to take it as a another important introduction, that is the terminology of the thermodynamics. So the terminology of the thermodynamics is, the basic concept of the thermodynamics is we need to learn some foundational topics we have to learn. So what are those foundational topics we will see in this class. The first you have to take the basic concept of the thermodynamics is, first we able to take it as a system. So what is your system? A definite quantity of matter bounded by some closed surface is known as a system. A definite quantity of matter, bounded by, a definite quantity of matter bounded by in a closed surface, so that we call it as a, according to the thermodynamics, we are going to call it as a system. So what is a system? A definite quantity of matter bounded by some closed surface is known as a system. Suppose you have to take the example, a gas containing in a cylinder with a movable piston constitutes a system. A definite quantity of matter bounded by some closed surface is known as the system. What is the example? A gas containing in a cylinder with a movable piston constitutes the system you have to take. So what is the second term? The surroundings. All those things which are outside the system and influence its behavior are known as surroundings. All those things, what are those things are there outside the system, whatever the things are existing in the outside the system and influence its behavior, so such type of systems we call it as a surroundings of the system. Clear? So such types of things we are going to call it as a surroundings. So this is the system you have to take. So this system influenced these things, so those things we call it as a surroundings. Now you are going to take it as a, this is the boundary, the system and surrounding we call it as a universe. Suppose you have to take, what is the universe? The universe is a system and its surroundings together are is said to be constitute a universe. What is the universe? A system and its surroundings together are said to constitute a universe. So these are the very, very fundamental terminology in the thermodynamics. So what are those fundamental terminology in the thermodynamics? First we are going to take it as a system. What is the system? A definite quantity of matter bounded by some closed surface is known as a system. What is the example of the system? A gas containing in a cylinder with a movable piston constitute the system. What is the surroundings? All those things which are outside the system and influenced by its behavior are known as surroundings of the system you have to take. What is the universe? A system and its surroundings together are said to constitute a universe you have to take. Clear? Now the types of the system. What is the types of the system we are going to learn? So here three varieties of the types of the systems are there. The first system is the first type you are going to take it as a open system. The second one is closed system. The third one is isolated system. So what is the open system? Suppose you have to take this one is a system and this one is the surroundings. The system and surroundings exchanging the energy and matter, such type of system we call it as a open system. So whenever the system and surroundings only exchanging the energy does not matter, such type of system we call it as a which system? Closed system. A system and surroundings neither energy nor matter not exchanging, such type of system we call it as a isolated system. Suppose here you have to see what is the system you have to take here. A system which can exchange the matter, a system which can exchange the matter as well as energy with its surroundings is called such type of system we call it as a open system. What is the example? Boiling of water in an open beaker. So we are going to take it as a open system. Boiling of water in an open beaker. So that is the open system. So what is a closed system? A system which can exchange energy but not matter. Exchange energy but not matter with its surroundings. Such type of system we call it as a closed system. A closed conducting vessel or pressure cooker we call it as a closed system example. What are the isolated system? A system which can neither exchange the matter nor energy with the surroundings. Such type of system we call it as a isolated system. What is the example of the isolated system? A closed vessel with insulated walls or thermoflask we call it as a isolated system examples. Clear? So these things you have to remember. So not only that, some more important terminology I am going to give to you. So what is that? Thermodynamic equilibrium. So what is the thermodynamic equilibrium? Once you have to see. The state of the system can be represented by three terms. One is pressure, another one is volume, another one is a temperature. So when these variables attain the steady value, so that is they are independent of time, then the system is said to be the state of thermodynamical equilibrium state. So once again you have to listen. The state of the system can be represented by the pressure, volume and temperature. When these variables attain a steady value, that is they are independent of time. So then the system is said to be in the state of thermal equilibrium or thermodynamical equilibrium. A system in which in thermal and mechanical and chemical equilibrium is said to be thermodynamical equilibrium. In a state of equilibrium, in the properties of the system are uniform. So and only one value can assign to it. So these are uniform and only one value is maintaining once you have to say. So thermodynamical equilibrium means two systems are said to be thermodynamical equilibrium when they are thermal, mechanical and chemical equilibrium with each other. So then that system we call it as a thermodynamical equilibrium system. Thermal, mechanical and chemical equilibrium. A system are said to be thermodynamical equilibrium when they are in thermal, mechanical and chemical equilibrium with each other. Those systems we call it as a thermodynamical equilibrium. Suppose some chemical compositions of H2O is there here. Outside and inside the pressure is the same. You have to take surrounding temperature is 25 degrees centigrade, water temperature is 25 degrees centigrade, you have to see. So what will happen? So in the thermal equilibrium, because of water temperature and surroundings temperature are same, water temperature inside and surrounding temperature is same. So that's why the system is in thermal equilibrium. So suppose you have to take a mechanical equilibrium because outside pressure and inside pressure is the same. So we are going to take it as a, so that system mechanical equilibrium is there. So chemical equilibrium because you have to take chemical composition of water is equal to H2O is the same entire the bottle. So that's why that system is in chemical equilibrium you have to take. So now once again you have to see what is the mechanical equilibrium when there is no unbalanced force, when there is no unbalanced force interior of the system and between the system and surroundings, then the system is said to be mechanical equilibrium. So this is possible only when the pressure remains constant. This is very important. Mechanical equilibrium can execute in terms of which parameter is remains constant. The pressure remains constant throughout all the parts of the system. Mechanical equilibrium means absence of pressure gradient. Absence of pressure gradient within the system. So no mechanical work between the system and surroundings. Such type of system we call it as a mechanical equilibrium system. What is the example? Ideal gas inside a container. Ideal gas inside a container maintains the mechanical equilibrium. So not only that, you have to see thermal equilibrium. A system is said to be thermal equilibrium if there is no flow of heat. If there is no flow of heat from one portion of the macroscopic system to another portion of the macroscopic system. So this is possible only if the temperature remains the same throughout in all parts of the system. A state of the thermal equilibrium can be described as one in which, so the temperature of the system is uniform. Which term is uniform? The temperature of the system is uniform. These are the key points in the thermal equilibrium. So what is the key point? A system is said to be thermal equilibrium if there is no flow of heat from one portion of macroscopic system to another portion of the macroscopic system. This is possible only if the temperature remains the same throughout in all parts of the system. A state of thermal equilibrium can be described as one in which the temperature of the system is uniform. Clear? So now you have to take a chemical equilibrium. A system is said to be chemical equilibrium if the composition of various phases in the system does not change with time. So the chemical composition does not change with time. So therefore the criteria for chemical equilibrium is the equality of chemical potential. So what is this? The criteria for the chemical equilibrium is the quality of equality of chemical potential. That chemical potential I have to indicated by mu. After some classes we have to go for that chemical potential also. Now you able to see the two major things, the behavior of the system. So two varieties of the behavior of the systems are there. One is macroscopic behavioral properties, another one is a microscopic behavioral properties. What are the macroscopic behavioral properties? Once you have to see, it describes the gross characteristics of the system. It can be measured directly in the laboratory. It can be directly experienced by our sense of perception. Macroscopic properties are not concerned with the structure of the system. So for example, you have to say pressure, volume, temperature, internal energy and entropy. These are all the macroscopic properties of the system you have to see. What is the microscopic properties of the system? It describes the internal structure, atoms or molecules, whatever it may be, of the system. We call it as a microscopic properties of the system. It cannot be measured. It cannot be measured directly in the laboratory. So it cannot be directly experienced by our sense of perception. It cannot directly experienced by our sense of perception. Example, masses, velocities, energies, momentas and so on, you are going to get it. These are the microscopical behavioral property. So now we will see how the questions you may get in your competitive examination. At what temperature the centigrade and Fahrenheit thermometers show the same reading? So at what temperature? Minus 40 degrees. So in the minus 40 degrees, so the degree centigrade minus 40 degrees centigrade, which is equal to a degree Fahrenheit minus 40 degrees Fahrenheit. So both must be same, in the same reading it should shows. Clear? So this is very important. So today is enough. Tomorrow we have to discuss with some more subsequent terminology in the thermodynamics part. This is the basic terms in the thermodynamic part. So please you have to inform to your friends who are preparing the CSIR exam. After master they need to go for the JL, DL or Polytechnic, any competitive exam. So like this theory nowhere you will get it. So please you utilize the chance and download our app and listen our classes. Thank you so much. So thank you.